12,500 feet below the Atlantic Ocean lies a ship that never truly sank from memory. For over 70 years, the RMS Titanic rested in complete darkness, untouched, unknown, slowly transforming from steel into legend. But in 1985, everything changed. When Dr. Robert Ballard's expedition finally located the wreck, they didn't just find a ship. They found a massive underwater crime scene, split in two, scattered across half a mile of ocean floor, holding answers to questions we'd been asking since 1912. The question was no longer where is Titanic? It became, how do we bring it back? This isn't treasure hunting. This is forensic archaeology on the most ambitious scale ever attempted. Scientists aren't trying to raise Titanic, that's impossible. Instead, they're doing something far more complex, reassembling her piece by piece, using recovered artifacts, digital scans, and cutting-edge technology to reconstruct not just a ship, but the story of what really happened that night. But there's a deadline. Microscopic bacteria called rusticless are literally eating the wreck. Metal that survived 80 years is now disintegrating at an accelerating rate. Within decades, Titanic may vanish completely. So began the most technically challenging recovery operation in maritime history. Every dive is a race against time, pressure, and the risk of destroying what you're trying to save. The debris field is chaos frozen in time, luggage, coal, machinery, hull fragments scattered across the seabed like a three-dimensional puzzle with thousands of missing pieces. Early recoveries were small. Porcelain dishes. Leather shoes. A child's doll. Each item meticulously documented, GPS tagged, brought to the surface in controlled conditions. Then came the big pieces. Sections of hull weighing tons. Boilers. Parts of the grand staircase. Each required custom-engineered lifting systems, months of planning, and nerve-wracking precision. The moment these pieces touched air for the first time in decades, the clock started ticking again. Saltwater corrosion accelerates dramatically in oxygen. Immediate stabilization became critical. Welcome to the hidden side of the Titanic story, conservation science. Every recovered piece is soaked in chemical baths for months, sometimes years, to remove decades of salt buildup. Metal artifacts undergo electrolytic reduction to stabilize corrosion. Organic materials like wood and leather are freeze-dried to prevent collapse. But the real breakthrough came from what these artifacts revealed. Metallurgical analysis of Titanic's steel showed it became brittle in cold water, a fatal flaw. Examination of rivets revealed substandard iron in critical areas. The ship's own materials contributed to the disaster. Every piece, over 5,000 artifacts recovered so far, is photographed, measured, chemically analyzed, and added to a growing digital archive. Not just preserving objects, but capturing data. This is where reassembly becomes possible. Using photogrammetry, laser scanning, and advanced imaging, researchers have created a millimeter-accurate digital twin of Titanic, both as she was, and as she is now. Fragments that broke apart 80 years ago can now be virtually reunited. Damage patterns analyzed. Stress points identified. The exact sequence of the sinking reconstructed frame by frame. Some pieces are physically reassembled in museums, creating walk-through environments where visitors can stand inside actual sections of the ship. But most of the reassembly happens in the digital realm, where every piece of the puzzle can be tested, rotated, and understood without risking further damage. Virtual reality now lets people walk Titanic's decks exactly as they were, not as Hollywood imagined them, but as forensic evidence proves they existed. And here's what we've learned: Titanic didn't just hit an iceberg. She was a cascade of failures, design compromises, material defects, human decisions, all converging in the worst possible way. The reassembled evidence has directly shaped modern shipbuilding. Double hulls. Watertight compartments that actually work. Lifeboat capacity for everyone aboard. Ice patrols and radar systems. Every cruise ship today is safer because of what Titanic's reassembly taught us. But beyond engineering, reassembly has restored humanity to the tragedy. A steward's jacket. A third-class passenger's suitcase. A love letter never delivered. These pieces reconnect us to the 1,500 people who never came home. Yet time is running out. Recent expeditions show the wreck collapsing faster than predicted. The iconic bow railing has fallen. The officers' quarters have caved in. What couldn't be recovered is being lost forever. Titanic is being reassembled not because we can raise her from the ocean floor, but because we can raise her from obscurity. Piece by piece, artifact by artifact, we're transforming a rusting wreck into something more permanent than steel, knowledge. She exists now in fragments, in museums, in laboratories, in digital archives, in lessons learned. No longer one ship, but thousands of pieces telling one story. And as the physical Titanic disappears into rust and memory, the reassembled version becomes her true legacy, a warning, a tribute, and a promise that we'll never stop learning from those who sailed into that cold April night.